All right. How many semesters do you have left?
Uh, Hopefully by the end of this year I should be done.
Oh, nice.
Yeah,
Well, you're right there, close too. That's good.
yeah. And then it's off to PT school.
Ah, there you go.
Yeah.
Do you know what specialty you'd want to do?
No, not really. I was thinking either I like joining a sports team or just like having my own clinic.
Oh, right. Okay. Sorry, you said PT and I was thinking PA in my head, but yeah, okay.
Oh,
PT. Yeah, that'll be awesome. That's a
yeah.
great career path. Oh, well, I haven't looked over anything and I'm hoping I can remember all this stuff.
Yeah. A little bit.
It's
A little
definitely
while.
been a little bit. Um, I'm still the most worried about memorizing all of these formulas, though, from this most
Um,
section.
well, let's see. Didn't he say something that we can use like some sort of sheet on the test?
Oh, did he?
Yeah, let me
I
check
didn't
here really
read that.
fast.
Let me read his
Um,
email again.
yeah, you are only allowed to use a calculator on the exam and the formula sheet provided.
Oh,
So I don't know which formula sheet he's talking about, but we do get something.
okay. Where do we get that?
I'm not sure.
Find that formula sheet then. Oh, next week's stuff's not open yet.
Oh,
Yeah, I want to see what this formula sheet is. Because, I mean, if we don't know what the formula sheet is, we don't know what to memorize.
yeah. Actually, do you know if this final's like comprehensive or
I
cumulative?
believe it is, yeah.
Okay.
Okay. Well, Is there a group quiz today?
Yeah.
Dang it. All right, well, I suppose we begin um, with the GHOA assignment.
Yep.
So begin by discussing any questions your team members had in preparation for the exam. If you are unable to answer a question, be sure to send that question to your teaching assistant and or instructor. Do you have any questions that I might be able to help you with?
I'm sure I have plenty, but I can't remember what they were because
That's where I'm at.
I pretty much forget everything by the end of the weekend. I'm just like, oh, this lesson's done. Time to do a memory dump.
Yep. That's kind of where I'm at. I'll remember as we go what questions I'll have. So, let's do some extension problems then.
Okay.
I decided to rip out a page so that I can flip through my notebook. I'm sure I'm going to be doing some of that.
Okay.
All right, well, shall we start with number 1?
Yeah.
Part 1.
I can't remember how we start these kind of problems.
Okay, so find both all solutions and solutions from 0 to 2 pi.
Wait, okay.
Um,
So basically, you take each section of it and set them both to 0.
Well,
Oh, wait, no.
let's see. We need to do the half angle identity formula. So this is all recent stuff, it looks like. I wonder if the final isn't cumulative.
Huh.
I wonder how we find out before Monday. It is a comprehensive exam, so be sure to review your exam 1A and 1B materials. There's our answer. So I think the materials we've been given for this section is for the recent stuff, but we still need to go back.
Mm.
So,
Okay.
so that's fun. All right, well.
Are you sure the first one for half angle identities?
I think so, because don't you want to cancel that 2 and the 2x? Because if it's already at 2x, you want to cancel that by dividing that x by 2, so you can find just x. And if you did the half angle identity, you would do that immediately. So, where's half angle? I forgot these ones are weird.
Yeah.
The half angle. I'm confusing myself now. So I feel like in the past we would have done the half angle so that it cancels the two. But if we use the double angle identity, we wouldn't have to change anything. Right?
So I'm starting to remember what you do here. So I think what you need to do, you need to make it so that it's just like one function equaling the other side. So like with the first one, you subtract square root of 3 from both sides, and then divide both sides by 2. And so you're left with sine of 2x equals negative square root of 3 over 2. And then you need to find which ones on the unit circle are negative square root of 3 over 2. So you got 4 pi over 3, and where's the other one? Oh, 5 pi over 3. So 4 pi over 3 and 5 pi over 3. And then you set each of those equal to the 2x. And then you just divide each side by 2. So x equals pi over or
I
2
think.
pi over 3 and 5 pi over 6. Did I make any sense?
Yeah. So at negative root 3 over 2, or when sine is negative root 3 over 2 in two places, and that is
4 pi over 3 and 5 pi over 3.
5 pi over 3. Okay, yeah. Okay. Okay, so what you have to do, I'm remembering now, you have to substitute the parentheses with another variable, so like y. So 2x equals y. Then we'll solve for y, which we decided was 4 pi over 3 and 5 pi over 3.
Yeah.
But if we want all of the solutions, then we have to do plus 2 pi k. So it's 4 pi over 3 plus 2 pi k and 5 pi over 3 plus 2 pi k. And then since it's a 2x, now we have to substitute our 2x back in. So we'll divide both of those answers by 2 to get the value of x.
Yeah.
Is that what you did?
Yeah.
Okay.
I got x equals 2 pi over 3 and 5 pi over 6.
Okay. So yeah, it's 2 pi over 3 plus pi k and 5 pi over 6 plus pi k to get all of the answers, right?
I think so.
So you got the answers within 0 and 2 pi.
Yeah.
Um,
What was that full thing that you said? 2 pi over 3 plus pi k?
plus pi k. Because remember, you have to add 2 pi k if you're wanting all of the answers, meaning that every single time you go around the unit circle, that answer is correct again.
Oh. Okay.
Does that make sense, kind of?
Yeah, this part I never really got.
Yeah, every time you go around the unit circle and hit that same point, it's also true.
Uh-huh.
So that plus, because 2 pi is all the way around, right? That's
Yeah.
360 degrees. So every 360 degrees, you'll hit that same point again, which is true every time you hit it. So every 2 pi times it by any whole number is true, and that's what k represents, is any whole number. It represents 1 or 2 or 3 or 5 or 69 or 5,000, right?
Okay.
It's true every time.
So what was that full equation that you said then?
So 4 pi over 3 plus 2 pi k. 2 pi being all the way around the circle, k being any number of times.
Okay. And that was it?
Yeah, and then, so that's equal to 2x, right? Now we have to
Okay.
find x by dividing that whole equation by 2. So it goes from 4 pi over 3 plus 2 pi k to 2 pi over 3 plus pi k.
Okay, where does the 5 pi over 6 come in then?
That's the second answer. Like there's, both answers are true.
Oh, so you just write them separately?
Yeah, like just a comma in between.
Okay.
But the 5 pi over 6, you also need a plus pi k.
Yeah.
Because every time you go around, it's true as well.
Yeah.
So.
Gotcha.
All right. Cool. Well, that helped me remember. Let's see if we can do number 2. This one looks like it might be easier to solve separately and not even multiply it together.
Yeah. That's what I figured it is.
think that's fair, but I'm not sure.
Yeah, I think it is.
Okay. Okay.
You got an answer?
Yeah. I'm gonna just check and make sure that you're in agreement with the teacher and yep, cool. Yeah, yeah, we're good.
Okay, so I'm a little
Did you
bit confused
figure it
on
out?
this.
What's that?
I'm a little bit confused on this.
Okay, so the easiest way is you get your equation for both of them so that secant x equals whatever, right?
Yeah. I
Then
got
from
that.
there, just do the inverse. Switch it to cosine instead of secant.
Yeah. I got
And
all that. The part that I'm hung up on,
okay.
so on the on the first part of the whole thing, I it comes out to cosine of x equaling square root of 2. But I don't know what square root of 2 over nothing equals on the unit circle.
Well, it's not square root of 2 over nothing. It's square root of 2 over 1.
Yeah.
And then when you inverse that, it's 1 over square root of 2, which is square root of 2 over 2.
Oh,
Yeah,
okay.
it's tricksy.
Okay.
Yeah, it's a formatting thing.
So then that would give us pi over 4 and 7 pi over 4.
Mm-hmm.
Okay, cool. I got it then.
And you got the other two as well?
Yeah, 5 pi over 6 and 7 pi over 6.
Cool. Yeah, and then so those would be the answers within 0 and 2 pi. And to get the
Yeah.
other ones, you'd add 2 pi k for each of them.
Okay.
Okay. I feel pretty comfortable with those. Should we try? I don't know. Do any of
Um,
those other three look appealing to you?
no.
I
I didn't do.
don't mean appealing, really, but
So what we got here for this? Oh, we're just verifying stuff.
yeah.
That's not too
Let-
bad.
Let's do the first one because I need a refresher.
Okay.
I actually don't know how to do this.
Still working on it.
Okay. Calling to the dishes.
Thanks, Glenn.
All right, I have no clue how they did this. I'm even looking at the answer key right now, and it still doesn't make any sense.
Really?
Yeah.
Okay, I started to do that, and then I didn't know where to go from there.
Where did they get cosine x cosine 2x minus sine x sine 2x?
That would be,
Where does that come from?
that's the sum and difference identities. So cosine A plus B, or cosine alpha plus beta, sorry.
That was cheeky.
Yeah, I started to do that and then forgot what to do next.
All right, I get it now. Stupid, but I get it.
Okay, yeah. That one's not super fun, but I guess it makes sense.
Yeah.
Well, let's pick one further down the line in that section just to see if we can do it.
Okay.
Do you have any of those you're itching to try?
Just the one where it says 0 equals 0.
Oh. Yeah. I agree. Let's try the, I don't want to make it too hard. Dang it. All right, let's try the secant squared x one, second to the last.
Okay.
Secant squared.
Okay, I got it.
I'm not quite there yet.
Okay.
Did you solve the right side or the left side?
I saw the right side.
Where did you go after 1 over 1 minus sine squared x? Or did you do that?
Wait. Repeat that one more time.
1 over 1 minus sine squared x.
1 over 1 minus sine squared x.
You may have done it differently, but I got to this point. Whether I should have or not, that's where I'm at.
Okay, so let's see here. Did you use the cosecant to 1 over sine?
Oh, you know what? I know how to solve it from here, but I'll bet we solved it way different.
Probably.
Because I feel like we've done this two ways where we have to solve one side completely to match the other side.
Yeah.
Or we've done it where we solve both of them and meet somewhere in the middle.
Yeah.
So, I mean, meeting in the middle is still the same math technically.
Yeah.
You just have to do it backwards to go up the ladder instead of down. But I think I know how to do it. Because 1 minus sine squared x, I'm guessing, is cosine squared x.
Yes.
It is, yeah. So now I'm at 1 over cosine squared x, which is equal to the left side, secant squared x. Right?
Secant squared x.
Yeah.
Yeah.
Okay, yeah, my math worked. We probably did it different though. Maybe. I'd show you, but my work's really small.
Yeah.
So I just want to see maybe what your thought process was versus mine. So I'll tell you what I did, and then maybe you tell me if you did it differently or whatever. But so I took the secant or the cosecant x both on the top and the bottom, and I made that 1 over sine x in both places. So it's 1 over sine x over 1 over sine x minus sine x on the bottom.
Yep.
And then I times both the top and bottom by sine x, making the top a 1 and the bottom left a 1 minus sine x, or sine squared x. So I have 1 over 1 minus sine squared x. How did you do it from there? I'm curious.
Okay, so I'm gonna go back a little bit.
Okay.
So I did like what you did before. I changed the
Mhm.
cosine x's into 1 over sine x.
Mm-hmm.
Except now what I did was on the denominator,
Mm-hmm.
you got 1 over sine x minus sine x.
Mm-hmm.
So I added those two together. So for that, you need to turn that sine x into sine x over sine, or sine x, sine squared x
Mm-hmm.
over. Add those together. So now you got 1 minus sine squared x over sine of x.
Okay.
That's all in the denominator still. So then
Yeah.
I flip that up into the numerator. And
And it
so this
cancels.
cancel out. And
Okay.
I'm just left with 1 over 1 minus sine squared x, which
Okay.
is 1 over cosine squared x, which is secant squared x.
Okay. Cool. Yeah, we did that second step a little different, but it looks like both ways worked.
Yep.
That's cool. Well, sweet. That works. Okay, let's try one of these from part 3 and then do the quiz. Shall we?
Yeah.
Simplify or solve? Um, I guess let's do the first one because I don't remember how to do it.
Okay.
Oh, this is the triangle one. Do we just use Pythagorean theorem to get the third side?
I think so.
Trying to remember how we did that. Yeah, definitely that. Okay. Oh shoot, I was doing that wrong. Okay. I got my answer.
What'd you get?
20 plus 3 root 119 over 60.
I think that's close.
Let me see what he got. Minus 20. Hang on.
So with that cosine of 3/5, and you solve for it, it's a negative 4/5.
Oh, good call.
Yeah, that tripped me up too.
I forgot about the direction.
Yeah.
Negative 4 fifths. Okay. So that makes it a negative 20. Okay. As long as I remember the positive negative situation, I think I'm in good shape
Yeah.
on those.
Mm,
All right, what do you say we go for the quiz?
I'm down.
I mean, if we're being real, we could spend 12 hours on this stuff.
Yes, we could, but let's not.
Let's not do that. Okay. All right.
So for the first one, I got 2 cosine x.
Just 2 cosine x?
Yeah.
I'm not done yet, but I'm at 2 cosine x over 1 minus cosine squared x. Did you happen to pass that point?
Yeah.
Okay. So the 1 minus cosine squared x can go to sine squared of x, correct?
Oh, wait. Hold on.
Or is
Oh. Okay, hold on. I screwed up.
Well, if you can catch it yourself, that's a good sign.
Huh.
I just forgot how to determine like what's simple enough. You know?
Okay, so now I'm at 2 cosine x over sine squared x.
That's where I'm at. Question is, can we get more simplified or not?
Well, I mean, we could. Wait. We could get 2 cotangent over sine of x.
Yeah,
Yeah,
that's considered more simplified, right?
I say so.
Oh, okay. And then we can do 2 cotangent x cosecant x. And now we're fully simplified. Because cosecant is 1 over sine.
Oh, okay. So you're saying 2 cotangent x times cosecant x?
Yes.
Okay.
I think that's our final answer. That seems very reasonable to me. Are you good there?
I think so. I can't seem to find any other.
No, I think that's great. Having no fraction is kind of what he wants.
Okay.
So, yeah, I think we're good. Actually, let me think. Cosecant. Yeah, we're good. Solve the following equation for all solutions. So that's different than verifying it, right?
Yeah, it's pretty much I think it's pretty much the first problems that we were doing today. So he didn't give us a range.
I thought they had to equal 0, or like,
Yeah,
they pretty much always started equaling 0.
yeah. So all you need to do is subtract cosine of x from both sides,
Okay.
and then you set each part of those to 0.
Okay. Actually, I don't think you can set both of them equal to 0 yet.
Why not?
To do that, they have to multiply to each other, but the cosine is being subtracted from the sine 2x.
No. So like what we did in the first problem. So you set sine 2x to 0, and then you set negative cosine of x to 0.
Right. Yeah, I don't think you can do that yet because, like in our second problem of today, they were multiplied, right? And so you could just take each separate portion, but these aren't multiplied, it's subtracted from the other. So I think we have to do the sine of 2x thing. Crap. I'm getting confused.
So, okay, instead of subtracting cosine, what if we divided it each side by cosine of x?
I figured out how to do it, I think. And if you divided both sides by cosine of x, then you'd have sine of 2x over cosine of x equals 1.
Yeah.
Which I guess you could do, but I figured out how to subtract it over and make it work.
Oh, okay.
So, okay, I'll explain what I started and then maybe it'll make sense. So I just subtract the cosine x over. So I have sine of 2x minus cosine x equals 0.
Okay.
Okay. And then, so sine of 2x, using the double angle identity, the sine of 2x part is equal to 2 sine of x cosine of x.
Okay.
And then I do that minus cosine x equals 0. And then I can factor out a cosine x.
Okay.
And then I have two things multiplied to each other that I can set equal to 0 separately.
Okay, I gotcha.
And we have to solve it for all solutions, which means we need to add 2 pi k to every answer.
Okay, I got it.
Sweet. Oh. So you got pi over 2, 3 pi over 2, pi over 6, and 5 pi over 6.
Yes.
All of which you can add 2 pi k to for all of the answers.
Yeah.
Cool. All right. I concur. Number 3. Verify. I'll be back in just a second.
Okay. Okay, I think I got number 3.
All right. I'm just starting, so maybe you can start on number 4.
Okay.
Did you solve one side and get the other side, or did you meet in the middle?
I'm out in the middle.
Okay, because I think that's going to be easier for me too.
Yeah.
Okay. Alrighty. So sine of x, cosine of x.
Yes.
Well, that actually was not bad at all. It looked
Yeah.
scary, but then when you realize the cosine pi over 2 minus x is just sine of x,
Yep.
that makes it easy. That would take forever without an identity, though, I'm guessing.
Oh yeah.
Uh, did you get to the point where sine of x equals 1/3?
Nope. I'm still trying to figure out this polynomial.
Like to factor it?
Yeah.
Gotcha. You want me to tell you?
Yeah, tell me.
Okay. So 3 sine of x minus 1 times sine of x minus 1.
Oh, they're both -1?
Yeah. Because if the third number is positive, then the signs have to be the same. And if the middle number is negative, then at least one of them has to be negative. So we know that they're both negative.
Oh.
Yeah. And then if you multiply it back, it works out.
What do you know? Well, you got to the part that you talked about, but I don't know what sine of x over equaling 1/3 is.
Yeah, that's kind of what I'm stuck on. I have no clue what to do with that. Like sine equals 1 at 0 and 0 and pi. But
Yeah.
but yeah, I don't have a clue what the other part is. Let's see what Wolfram Alpha says. Yeah, it doesn't solve it here either. It just shows inverse sine of 1/3.
So is that it then?
I don't know how else to solve that and get an answer that's not a decimal.
Yeah.
So, but yeah, I mean, I don't know. I feel like that's fair. I mean,
Yeah.
it's still technically correct.
Yeah.
um, I just don't know how to express that that's going to lead to two separate points that are
Yeah.
valid. Because if you plug it in a calculator, you only get one.
Right.
Although now that I think of it, on our homework, we did have to use calculators for some of these, and we got decimals. Do you remember that?
No.
Yeah, I remember having to do this, and so I'm going to calculate it out and add that in as well.
Okay.
And then, you know, if you wanted more information, at least it's here.
Yeah.
All right, well, that's as good of an answer as I think we're going to get.
Yeah.
So just so you know what I'm putting, I got x equals 0, pi, 0.34, and 2.80.
Okay.
So basically the 0.34 came from plugging sine of -1 or inverse sine of 1/3 into the calculator.
Uh-huh.
And then I did pi minus that amount to get the other side. Pi being 3.14 whatever radians, you know?
Oh, okay.
Because technically all these terms are radians. So,
Right.
yeah, so Okay. I think that's it then.
Alrighty.
Well, good luck on the final. I know
Yeah, you too.
I'm going to have to do some more review before I'm done, but I don't know. I feel pretty comfortable with the recent stuff now, I think.
Yeah.
He didn't mention how many questions it would be, did he?
I don't think so.
I wonder if it's longer than a normal test. It probably is, but I don't know. I wish you would open it for this weekend because I don't want to have to mix that in with all my other finals.
Yeah.
But I guess I have to. Well, all right. Well, I didn't realize, but yeah, this is probably our last hangout then.
Yeah, I guess so.
Bittersweet.
Yep.
Well, it was a good semester.
Yeah. Good working with you.
Yeah, you too. I think despite our small group, I think we did well.
Yeah.
Yeah.
Can you imagine what it'd be like if we had like 2 other people?
Yeah. Yeah, it would either be way easier or way harder.
Yeah.
Because, yeah, I don't know. With my past experience with online classes, usually there's one person in the group that just is really smart and does all the pre-work. And then we
I
just
know.
sit there and ask him questions the whole time.
Yeah.
And so, I don't know. It was good that it didn't turn out that way because we were just figuring stuff out together the whole time.
Yeah.
So I think it turned out well. Well, I'll see you later then. Good luck on the test. Good luck on graduation and everything.
Yeah, you too.
Appreciate your help and getting me through a lot of these questions and not leaving me in the dust too much.
Yeah, I'm just trying to keep up with everyone else.
Well, you're doing good. So, well, let me know if you have any other questions that you stumble upon in your studying before the final,
Okay.
and otherwise, peace.
Well, see you later, man.
Okay, yeah, see you, Tyler.